So there was a recent posting on the archive, and this is related to the silver gold nanostructures and reports of um, signatures of superconductivity. So I want to give an, my review of some of the key data sets that were reported. Um, so we'll get right into it. Figure 1 um, shows a picture of the sample with the 8 electrodes, and then this is an AFM, and um, this is some line cuts showing the surface roughness, and then two terminal IV curves between some of the leads that are numbered here, and then these transitions that were reported um, for the same device, presumably. So really, I've been expressing interest in understanding the two-terminal IV characteristics. So it's nice that they were provided in this update. However, the resolution here is not so good, and it's really not at the level that one would like to really make sure that there's ohmic contact um, between these leads. So if we zoom in here to this panel, um, you can actually already start to see an anomaly here. And I'm going to zoom in even more. Of course, I can't keep zooming in because this is a rastered image of data. But I think you can see that basically there is this gap here between the positive side and the negative side, and this gap has units of about 50 millivolts. And my argument is that this is really basically what you would expect to see if there was some kind of barrier between the current carrying leads. And this was discussed in a post that my colleague and I had provided last year in August. So there's also in Figure 4 some very interesting data. Was actually pointed out to me by a friend, a colleague. I had trouble getting past Figure 1, but he was he had pointed out this correlation between the onset of what is claimed to be superconducting state. Notice the scale for the 4-terminal measurements is on the right, so it's going to 0, and the change in a corresponding increase in the 2-terminal resistance that coincides perfectly with this transition, and it's even sharper in the heating cycle. So there's some hysteresis, and but notice how sharp this transition is. That there's when you're heating, and let's say you're increasing the temperature, suddenly as soon as the resistance becomes finite, or whatever it is, 0.5 ohms, there's a sudden drop in the 2-terminal resistance. So this is really unusual behavior, especially if one were to interpret this as the onset of superconductivity that is being controlled by temperature parameter. First of all, it's extremely sharp, but the other thing to note is how pervasive this signature is. That it's clear that it was produced in many samples, many different devices, and although the range of this effect is basically varying from one device to another, in some places it was as large as 10 ohms. So this is then basically interpreted as a contact resistance, and that is somehow happening exactly at the same time as the superconducting transition. Now, I would argue that there's a very natural explanation for this coinciding of two-terminal changes in resistance and this apparent onset of superconductivity. Four-terminal zero resistance state could come if the leads themselves become isolated from the current path. But one thing that you can note from comparing these two diagrams, so this is supposed to be like the normal state, and this is one in which you would see zero resistance. If you look at the sort of pink area, you see that there is actually a much bigger area here than there is over here. What that means is that there are fewer paths for current to flow in this state compared to this state. So here you have all the bottom regions, current can flow from source to drain, as well as at the top. And here you have those top paths, but you don't have the bottom paths. So there should be less resistance, two-terminal resistance, in the right diagram compared to the left one. So the idea that there would be a transition where the voltage probes become isolated, you would in fact predict that there should be an increase in the two-terminal resistance, and this is exactly what is reported, and this is seen apparently in all of the samples. So the higher two-terminal resistance is associated with this zero four-terminal resistance, and then the lower two-terminal resistance is coinciding with the finite or non-zero four-terminal resistance when the voltage probes are in fact connected to the current paths. So to summarize, this new manuscript, in my opinion, provides compelling evidence that the voltage leads are becoming isolated during what is claimed to be a superconducting transition. And there are two sets of data that are provided from Figure 1, the roughly 50 millivolt threshold, which is not well resolved in the data, but does seem to be clearly there. So this voltage threshold is actually seen in the two-terminal IV curves. So if you really wanted to know what was going on, you just need to basically provide a higher resolution IV curves to see what's happening. And then the second thing is this telltale resistance change, which is not coming from contact resistance, but actually coming from changes in the bulk sample, that the number of paths from source to drain is being reduced with no need to have a change in the contact resistance in order to observe this kind of effect. So the last thing I want to point out is that I do know that this the previous manuscript, not this one, was submitted to PRL for review. I have read the referee reports from all three reviewers, and that's because I will admit to being one of the reviewers. But I don't know who the other two reviewers are. They provided their own independent assessment of the manuscript. I urge that the reports, which I expect to be in the hands of the authors at this point, that they should be shared by the authors publicly. I will not do it myself, but I think that in the interest of transparency, this feedback from the scientific community, again, these are essentially anonymous reviews from scientists who've been asked to review the work. Again, my review is included in those, so I'm going public in some sense. I also want to point out that there are many more reports that are starting to emerge claiming superconductivity in these gold and silver nano complexes. Um, as far as I can tell, none of the reports really properly address the possibility of percolation in a convincing way. And I'm referring to these two papers in particular, and I may have missed some other ones. Um, and I hope that I mean, this is science. It just happens to be happening at a more sort of public forum because of the nature of the claim, which would be truly remarkable. And I would love to have a room temperature superconductor. Unfortunately, I don't think that is what is being seen in these experiments.